So to recap quickly, in previous weeks we covered variables, data types, conditionals, loops, and functions. And then last week we had lists, tuples, and dictionaries. And this week we'll cover the last, let's say, fundamental building block to really understand programming, and that is classes. So we're going to cover object-oriented programming, polymorphism, and just classes and objects. We'll get into that now, and after that, we'll basically be ready in the sense that we'll know all the main basics of Python that we need to understand before we can get into some specific works like making games or making websites or doing some neuroscience related research or work of some kind, and just anything, which we'll cover next week. All right. Uh, as always, if you have any questions, feel free to interrupt me either in chat or in microphone, doesn't matter. And yeah, I'll share my screen now. Okay, I apologize. Mhm. Now does everyone see my screen?
Yes.
Okay. All right. So let's just get straight into it. So until now, any code we wrote was always written straightforwardly, like we would say some like if we had to calculate the area of a triangle, for example, a right triangle, we would say that side A is equal to, let's say, 4, side B is equal to 5. Then we would say that area is equal to side A times side B divided by 2. Then we would print area of a triangle is, and then we would write area. By the way, we can print text like this with commas. This will work. So any code we used to write was just straightforward like this. The problem with this approach is that sometimes we notice that we are repeating similar operations on different objects. Now, here's what we might mean by objects. Suppose we have a lot of figures, like a lot of triangles, and we want to calculate, and we want to do some operations on each of them. Like maybe we want to calculate the area of every triangle we have. Or maybe there's a more complex case, like if we're using the human brain, for example, maybe we have different brain regions for which we want to apply some stuff. So as we remember from before, we have functions that can do things like calculate area and say side A and side B. We can return side A and side B by 2. And if you remember also, let's say calculate area of right triangle. These are the functions that can encapsulate some logic for us. Or maybe it can say this is the area and then it can print it to the screen. Area of right triangle is in an area. But so functions allow us to basically group some pieces of code together so that we can then later call it and say like this. Calculate area of right triangle side A and side B. But we might also go level up and let's think of it this way. What if we have multiple related functions for an object? Like suppose we want to know the area and the perimeter of a triangle, maybe, for example. In this case, we would say also calculate the perimeter of a triangle. In this case, again, of a right triangle. And how might we do that? Well, we know that perimeter is side A plus side B plus side C. But except, of course, we don't actually have the side C, so we would have to calculate it somehow. Let's just call it hypotenuse to be clear. And in this case, we might also add a separate function. Of course, we could do all of this without functions, but you'll see in a moment why we might do it this way. So if we want to calculate the hypotenuse of a right triangle, we would just say that let's say c squared is a squared plus b squared, and hypotenuse would be the square root of that. So let's just return this here actually. Return hypotenuse. And so here we would say hypotenuse equals calculate hypotenuse for a and b. Now what are we doing here? Let's see. We calculated the area of this triangle and we calculated the perimeter of this triangle from here. We can see here that if our triangle has sides of 4 and 5, then the area will be 10 and the perimeter will be around 15.4. Now, sometimes we encounter situations where we have a lot of repeating logic. Like now, let's say we have different sided triangles. Like let's say now some x equals, I don't know, 12 and y equals 5. And in this case, we want to know the area now for this triangle. And that'll be 30. And yeah, so on. Now, thing is, sometimes when we notice that we are applying similar calculations to different objects, we might realize that it would be better for us in terms of encapsulating the code to somehow keep these three functions together. And Python actually allows us to do exactly that with classes. And today, classes are all we're going to be talking about. And we're getting to examples just now. So we'll see a more elegant way to write this in a moment. But now let's start with the basics. Let's first figure out what classes are and how they would help with making this code better. So first, let's take a very simple example. Let's say class would be triangle, for example. And this is how we write it. This is just a class. And here we would write any fields that such an object should have, as well as any functions we might want to call on it. So first of all, when we think of a triangle, we can think of it as, in fact, let's just say right triangle just to be precise. And any right triangle would have side A and side B. So we might say that A is equal to 10, B is equal to 6, or whatever. It doesn't really matter. But the point is, whatever it is, a triangle should have exactly these functions. And here's how we would put them here. We would just keep the same thing, but we would pass the parameter as self. And in this case, this would actually be doing the same thing. But here's the benefit. We would now be able to create an object of type right triangle. Let's say triangle 1 is equal to a right triangle. Now we would be able to say like this. And this would keep the logic more concise. Now, thinking of it this way might be a little bit confusing. So let's break this down into what this actually allows us and where this can lead us. Let's start with some samples. So first, let's say that we have a bunch of animals and we want a way to organize their behaviors and just their features. We'll see in a moment why doing this with classes would be better than just using variables normally. So let's start with the basics. Let's say we have a dog. We would say class dog and then a colon. Then first we write pass, which is like a placeholder so that Python doesn't throw an error when we don't have any content yet. So like if I do it like this, that'll be an error because of the colon it expects something to be here. So we write pass until we figure out what we want to actually put there. Now, generally, a class is like a blueprint of what we want to do. Like, for example, you can imagine if we're going to build a house, or let's say we're going to build 10 houses on a street that are going to be exactly the same, or almost same. We would first define the plan of what a house should be like. In this plan, we would say that the house should have, I don't know, windows, doors, bedrooms, kitchens, bathrooms, and so on. And then we would actually create houses based on this description. So a class is like a description for what a dog should be like. Right now, this is an empty description, but we'll add things here. And then we are able to create objects of this description. So then we can say, this is my dog, this is someone else's dog, and so on. And in this case, this is one dog, and this is another dog. So what this allows us to do is, until now, every data type we dealt with was either a number, or a string, or a Boolean, or it was a list or dictionary, which is a bunch of those. But now we are able to create new types of objects and we can work with them similarly. So first, let's start with the basics. Let's see what's going on here. Let's run this code first. And let's see what got printed in the terminal. So you can see here, this line, print my dog, which my dog is a variable that holds an object of type dog, dog being the class that we defined here. Here you can see it just says a dog object. And this line, type of my dog, just says the type is main.dog. It says main because it assumes that whatever we execute is main. We can ignore that right now. But you can see that it says that our object is of type dog. Okay, but right now this is not very useful. So let's start giving it some principles. First of all, let's say that each dog has some height. We can say that height is equal to, I don't know, 5. And let's just say that its weight is equal to 10. Now, if we wanted to know the height and weight of my dog, we would say my dog.height and my dog.weight. And just like that, we would see 5 and 10. But now what happens if I want to create a different dog, another dog, calls dog, and set his height and weight to something else, like 7 and 12, for example. Like let's say we have two dogs and they're just different size. In this case, we can see one dog has a size of 5 and 10, and the other dog has a size of 7 and 12. The equivalent of doing this without classes would be to say some kind of variable for my dog height equals 6, my dog weight equals 11, or another dog height equals, and so on. Like it will be like this without the classes. And the purpose of doing it with classes instead is that this allows us to contain similar logic together. And more importantly, it allows us to hide some problems from the users by using functions from inside the classes. And we'll get into that in a moment. But for now, I just want you to understand that this would work the same way as if we just used variables. It just allows us to group similar logics together. Now, until now, every dog we create, let's see here as well, at first is going to have the same parameters. Like you can see, this dog was created with 5 and 10 as well. But then we changed the parameters of height and weight, and it showed up here. Now, the reason why that is useful is because we can have many different dogs, and they can behave differently. And in fact, right now we can also see that we are kind of repeating this printing logic. Maybe we can put that inside the dog as well. Like we can say, print your info. And we have to pass in the self so that we can know which dog we're talking about. And we'll see what that means in a moment. Let's just write it like this. So we say print height and self.height and weight self.weight. So self.height is going to give us whatever we had in here, and self.weight is going to give us whatever we had in here. So we need to specify self because without it, this height and weight are not clear. Because remember, right here we created two different dogs, and they have different sizes. So now that we have this function, in here we can just say my dog.printinfo, another dog.printinfo, and again another dog.printinfo. And now we can run it like this. And here we can see that for the first dog the height was 5 and weight was 10. The second dog started the same way, but then changed his height and weight. So this sort of allows us to encapsulate the logic. The similar thing we could do without the classes would be to just say print dog info, and in that case we'd have to pass the dog. Then we would say dog's height is dog.height and dog's weight is dog.weight. So this is pretty much equivalent to this. It's just that instead of passing the dog, in here we say self so that each dog knows that it's talking about itself. And this allows us to say another dog.printinfo. Instead of saying, like to call this one, we'd have to say print dog info with my dog. But alternatively, we can say my dog.printinfo. This is the difference between the two approaches. And we'll see the benefit in doing this when we get to more complicated examples. Okay, now there is one more thing we could improve on here, and that is that what if we don't want to start with the same default values for every dog? But what if instead we want to be able to say that I want to spawn one dog with this height and one dog with this weight? Because, for example, when we create variables, that is certainly the case, that we can right away specify what values we want. And in fact, with classes, we can do that as well. And here's how we would do that. We would say define init and self, and then we would say whatever starting variables we want. Like in this case, self.height is 5 or self.weight is 10. Or alternatively, we could specify precise variables in here. But let's see what this is and when this will execute in our code. Let's start from here. Let's just run it with a debugger to see what's going on right now. So you can see here, when we come here, we want to create an object of type myDog. We call dog, and what it does is actually this dog behind the curtains will call the init function defined in the class dog. And if we don't have an init function defined manually, it will just create it with assigning just default values to variables. In this case here we see init self, and this is just a syntax for classes constructor. So here let's in fact say constructor. Here we call the constructor. A constructor to create a new object of class dog. So every time we call this constructor, we come in here, we set the variables to certain values, and now we can see here in myDog, there we have height of 5 and weight of 10, and we can print that to the screen. We can now create another dog, and we can also find another dog's values in here. You see their height and weight are both 5 and 10 right now. But now, once we get in here, you can see the height and weight of the first dog is still 5 and 10, but for the second one it became 7 and 12, and we printed that to the screen as well. Now to make this even more valuable, what if instead of writing it here, we could assign those values here? We would say height and weight. And in this case, we would say self.height is height, and self.weight is weight. And of course, we could name this something else, like, I don't know, y and x, or anything really. And this would work just fine as well. Like y and x. So it doesn't have to be the exact same name, but it helps to be the same name for readability. So let's just return this to height and weight. And we'll see in a moment why this is useful. And now that we have defined the constructor to work like this, in here when we call dog, we must actually give those values. So let's say the first dog will be created with 4 kilos and, 4 meters tall, 8 kilos weighing. And the second dog will be, let's say, 3 and 7. Let's see what difference that would make. So this is kind of like a function, you can tell, but it's specifically for creating objects of a class. So we come in here and we see that height is set to 4 and weight is set to 8 because of this line. So now we assign the height of this dog 4 and the weight of this dog 8. And we can see here we have a dog with height of 4 and weight of 8. And we write that to the screen. Then we make the next dog. You can see here it's 3, 7. But we can change its height and weight anyway. And it will become 7 and 12. So these are some of the main things that we can do with a class, which is to basically group these different fields together, the height and weight in this case for a dog, and then call some functions on them. And this is just a constructor which lets us create the object with some starting values. Now let's dive a little bit more into what more we can do with classes. And believe me, the more you see the usage of these classes, the more you will understand their benefit. So it's alright if at first it seems like unclear why we would use this as opposed to just writing normal code. And in fact, in Python, very often we might not use classes and we might just write normal code like without classes because you could get the same behavior without classes. But it's very useful to know what classes are and how they work because sometimes we can need them in very different cases. All right. Especially in neuroscience projects, sometimes you might not create new classes yourself, but you might have to understand the classes that other people created. So it's very useful to go into it. So this is an example right here. I'm looking at a class which you can think of as looking at a code that someone else wrote, because we did not see this being written line by line. But let's analyze this. Let's break this down, and actually this will make a lot of sense. So here I would say that we have basically 3 stages that we need to analyze. Stage 1 is right here, defining the class. Stage 2 is right here, creating two different dog objects. And stage 3 right here is doing stuff with these dogs, accessing their attributes in this case. So let's only worry about stage 1 first, then only stage 2, and so on. So let's see what we have here. We know that we can ignore the comment lines. They don't actually do anything. They're just there to help us describe things. So we have class dog like before. And we have a constructor here. Def in itself is just, we have to write this for a constructor. And we pass it the arguments name and breed. So like, I don't know, what's the name of my dog and what breed it is. So like, is it a retriever? Is it a shepherd or whatever it is? So first we print to the screen a new dog object is being created. Then we assign this dog name and breed. So far, this is a straightforward work. All right, if you get any questions, feel free to interrupt me, and we will discuss any part in better depth. Now here's the thing. We defined what the class dog is, and now we must create the actual dogs. So let's say we create two dogs and assign them to these variables. So the first dog we create is called Fido, and it's a type of golden retriever. And the second dog we create, we call him Buddy, and he's a pug. So you can see here, this is dog 1 and this is dog 2. And now that we have these dog objects, we can do something with them. In this case, all we do is we just print their name and breed to the screen. Let's see what that looks like. You can see here, a new dog object is being created. A new dog object is being created. Dog 1 is named Fido and is a golden retriever. That was written because of this line. And dog 2 is named Buddy and is a pug, as you can see over here. So far, so good. This is just a class. It has a constructor where we assign these values. And then we can read out those values by saying dog1.name, dog2.breed, and so on. Because dog1 holds this object and dog2 holds this object. So we create classes by calling the constructor. And that's how it is called. So here you can see we pass two arguments, Fido and golden retriever. And that is because here we ignore the self part. We have two arguments, name and breed. And that is what happened here. All right. Right now, are there any questions? All right, we will proceed now with more examples, and then we'll get back to reinforce our understanding. Okay, let's see here. Now this is a slightly more complicated example, but we'll similarly break it down and it won't feel like a big deal at all. So let's say right now, this is again stage 1, defining the class. And in fact, let's just ignore the rest of the stages for now so that we can just focus on this. So what do we have here? Again, we have class dog. We say that number of dogs starts at 0. And this is a class variable. It's a static field. It belongs to the class and not a specific object. Yeah, this is a point that we did not really address before, which is that we can still define variables like this, but the purpose of those would be that they will be the same value across every dog that we have. In fact, let's stay simple here for that. Let's say amount of legs plus 4, because this does not depend on the type of dog we have. Every dog has 4 legs, every healthy dog at least. So in this case, if we wanted to know how many legs a dog has, we would say each dog has dog1 that amount of legs. That is one way we could say it. Or another way to say it would be just dog that amount of legs. And this would work as well. Because in this case, this is called a static variable. Static or class variable. And that means it is same for every dog object. So this will not change its value for any dog object. And if we change it once, like we say dog.amount of legs is 3, now we can see dog1's amount of legs is also 3, and dog2's amount of legs would also become 3. Because when we define static variables, and static variable is anything that we write without the self, so that's why we have self dot in here, to make sure that this only belongs to the specific dog and not every dog. But anytime we write without the self, will belong to every dog. So in this case, every dog has 4 legs, is what we mean. And we can see it as dog dot amount of legs, or any specific dog dot, and then the field. All right. Now let's get back here. In this case, we have a static field that just keeps count of how many dogs we have. And the way it would work is that every time we create a new dog, which happens when we call a constructor, we will increase the amount by 1. So at first it starts with 0. This is a class variable, it's a static field and belongs to the class, not a specific dog. So it starts with 0, and in our constructor we have everything the same. We assign the name and the breed, but then we increase it by 1 so that we can keep track of how many dogs we have right now. So also, additionally, we did some new things here, and let's go through them as well. First, this one. This is an instance method, which means that every dog will have its own version of it. Here's what it does. This allows a dog to bark. And bark just says, this dog says woof. So the name of the dog and says woof. And we also have a class method in here, which is a type of function where and by the way, yeah, let's just clarify this. Method is a function inside a class. That's it. That's what a method is. So you might see a function and a method used interchangeably, and they're basically the same thing, but when a function is used inside a class, it's called a method. That's it. So you might hear me say, this is a class method or this is a class function. They're the same thing. All right. So what is this? A class method, as opposed to an instance method, is something that's same for everyone. So the class method can't really rely on having any specific dog. So instead it has to give us only the static variables and cannot access the name or the breed because this only exists for the dog class itself, not for any specific dogs. And in this case it makes sense because in this case we just want to get the number of dogs, which doesn't depend on any specific dog, it just depends on how many there are in total. Okay, let's start using them so that it becomes more clear why we did it this way. Let's create the dogs. So we created the dogs right here. In fact, let's put some breakpoints in here so that we understand what's going on. And then let's put a breakpoint here as well and here as well. Let's go through this code, step through it, and we will understand what is going on. Okay. There we go. So we come here, I put the breakpoint so that we can see what's going on. And we see, at first we're going to create the first dog. We come in here, we set the name and the breed, and the number of dogs right now is at 0. And now it became 1. You can see it here, I believe, in class variables of dog. We can see here number of dogs is 1. Now the name and breed have been set for another dog and the number of dogs became 2. We can see here the first dog has name of Fido and a breed of golden retriever. Number of dogs is 2. Every specific dog can see this number of dogs variable, but it belongs to the entire class, not to any specific dog. So now we have created 3 dogs. And now for the first dog, we're going to call the bark. And here we see Fido says woof. We said Fido specifically because we called it on the first dog, and that's the name of it. All right. So this is where we were. You see my screen, right?
Yes.
Yeah. Okay. All right. So here's what we were doing. We were discussing that in our class dog, we had a static variable, also known as a class variable, number of dogs, which belongs to the entire class, not to any specific dog. And we also had a constructor, which lets us to create specific dog objects that we did here. We made 3 dogs. Each dog will have its own name and its own breed. And each time we create a dog, we increase the number of dogs right here. So each dog can bark, and that just prints the dog's name to the screen pretty much and says Fido, says Wolf, or whatever. And also, the class of dog has this get number of dogs method that can access the number of dogs that we have in here. Yeah, it's common to just say class in here for class. And this just allows us to access this variable, pretty much. Yeah, so that's everything we need here. And here we can see, just as we said dog1.bark, we can say dog.get number of dogs. And that's how we can say there are now 3 dogs. Because we don't need to access any specific dog to get this variable. Yeah. We could even do it like this. Instead of writing that function, we could say just number of dogs, and this would work as well. Yeah. Now, you can see here the difference is if we say dog3.bark instead, then it will say Lucy says woof, because that's the name of dog 3. And so what this allows us is that this is a instance specific method because it takes the self as an argument and it lets us to access the specific name of this dog versus that dog. But this is a class method, so everything in here has to be same for every dog. So it can't access name or breed, but it can access like number of dogs because that's the same. Yeah, basically that's the idea here. And this is going to appear a lot. Yeah, basically there's class variables and there's instance variables. Difference being class variables are same for everyone. They can still change the value, but they will change it for everyone in that case. And the instance variables are, yeah, unique to each dog. I mean, they could be same. Like nobody's stopping us from making another dog for that is also Lucy and Labrador. Like that is allowed. But I'm just saying they could be different if they wanted. You can see here now 4 dogs. But yeah, if they wanted, they could be different. That's the idea. All right, those are the main concepts. And just another concept we need to cover is inheritance. Now here, everything gets a little more interesting, and we should spend a bit more time on this. Okay, so far, we always had everything in one dog. But what happens if we want to say that every dog can do these things, but some dogs can also do other things? That's where inheritance comes in, and here's what that means. Let's say that every dog has a name and has a breed, and let's say that every dog barks. But now let's say that specifically golden retrievers can also retrieve some items. So this is just another function that only golden retrievers have, but other dogs don't have. In this case, we would first call this one the parent class, and we would call this one the child class. And here's what that means. So the parent class is exactly the same code that we had before, nothing's different. But the child class is slightly different. And let's see what the difference is. First of all, we can see here it says golden retriever, then this opens and we can see dog written here. This means that golden retriever is a child of dog. And what that means is that golden retriever also has a name and a breed. And it can also bark. Like everything the dog had, golden retriever now also has. And in addition to that, it builds on that and can add the ability to retrieve. And you can see here, yeah, basically you can initialize to self and name. And in this case, it will just call the super init, which just means calling this initialize right here. And let's put some breakpoints in here so we can figure out what that means. Yeah, let's just go through this code. But you can see here, you remember to create a dog object, you have to specify both name and breed. But we decided that for golden retrievers, we only specify the name, and the breed will be set to golden retriever right here. Let's see what that means exactly by going through it with a debugger. And right here, we'll now see what's going on. So first we come here, nothing happens so far because we just defined the classes. But now when we try to create a golden retriever object, first we come in here into the constructor of a golden retriever, and where we see that the name is equal to body right here. And here we are calling super init. This is pretty much just call the constructor of a parent being the dog. So when we enter here, this is where we enter. And this time name is equal to body again. And the breed, as you can see here, is equal to golden retriever because we set it right here. And so it just assigns the name and the breed. And we can see here we have a golden retriever created. And his name is body and his breed is golden retriever. We can call bark on him just fine, even though this is a method defined in dog and not in golden retriever. Because golden retriever is a child of dog, it can access it just fine. So we can call bark on him. You can say here it says buddy says woof. But we can also call this specific function that only golden retriever has. Retrieve frisbee, we see. So here it says buddy is happily retrieving the frisbee. So you can see here the retrieve function takes self, which just means that it belongs to the specific dog. And then an item is just some variable that we made up. We could have not had it, we could have had multiple items, whatever. We call it an item so that we can say self's name is happily retrieving the item. So we see body is happily retrieving the frisbee. And then we come in here, we can take the breed or the name of the object and just write it on the screen. Breed of a golden retriever is golden retriever. So this is what inheritance allows us. And actually, we can go through another example of inheritance, which will be even more obvious. But first, let's take a moment to appreciate what is going on here. So we have a class called dogs. It has a name and a breed and ability to bark. And then we have golden retriever, which is a type of dog. So we say it's a child or subclass of dog. And for its own constructor, we only give a name. And in here, we say that call the parent's constructor because it has to be called to create the child object. And for name and breed, pass the same name, and for the breed, always golden retriever. And then we just add a new functionality of retrieve in this case. I will upload all of these codes into our Discord, and I will also upload this to YouTube, of course. And we will have some homeworks around this to reinforce the understanding of these concepts. But right now, let's go back to shapes so that we have another example. Let's just say classes samples 5 or pi. And here, let's say, for example, that we have many different shapes and that each of them has some area, weight, area, perimeter, whatever. For now, let's say we are dealing with rectangles, for example. Let's say we have a class of rectangles. We give it a constructor. Let's say that each rectangle has a width and a height. We would say that width is width and height is height. We know that the amount of sides that a rectangle has is always 4, because it's a rectangle, of course, it has 4 sides. And we also know that the angle is always equal to 90 degrees. So we can define them right here, because this is not going to depend on a specific rectangle. Every rectangle is going to have these properties, but the width and height will depend on a specific rectangle. Now let's say we want to get area for a given rectangle, so we say self, and we would say area is self.width times self.height, and we would return the area. So again, difference between return and print is that with return, this will just be put in whatever place called it without being put on the screen, whereas print would just put it on display it on the screen, but then we would not be able to place it in a variable. We could do both. We could both print it and return it, but generally you would only do one, and most of the cases you would rather only return. And now you can see calculate the perimeter itself. And to calculate the perimeter, we can just say it's twice width plus height. And we can return it. We can also say like print information about this rectangle, and we would say it's a rectangle with width and the height. It has an area of whatever calculate area returns, and a perimeter of whatever the perimeter returns. Right here, calculate perimeter. Now we can say that we have some rect1, which is let's say rectangle of size 5, 10, and rect2, which is of size 3 and 4. And maybe we print the info of the first rectangle and of the second rectangle as well. See here, first one has a width of 5 and height of 10. So it's an area of 15 and perimeter of 30. And similarly for second one. Now, what if we want to reuse some of this logic for a square? Like what if every time we're making a square, like let's say square, I don't want to have to write rectangle 6, 6 like this. Instead, I want to be able to just specify it with one variable. And for that, we might have to define a square. So let's say class square is a child of rectangle because, Every square is a rectangle, but not every rectangle is a square. That's how you can think of it. And in this case, if the constructor will only take one side, so we can just say side, or like length, or size, or even whatever we want to call it, we can say it's just side length. And in this case, because it's a type of rectangle, we still have to call this constructor on it. So we still have to say super init, and this is just the syntax we had to deal with, and the side length just given twice. We don't actually have to define anything else. Just like that, we can say a square is square of 6, and on this square we can print the info just the same. So right here we can see the square is a rectangle with width 6 and height 6 and has area 36 and perimeter 24. And in fact, if we don't like that it says rectangle, we can fix that as well. We can say name is generally rectangle. Say here softer name. But for squares, name will become square. Let's see if this works actually. We might have to fix it up later. Oh, it works. So we can see here that this name belongs to the class. So in this case, for rectangles, rect1 and rect2, it said rectangle with width 5 and 3. But for squares, it said square with width 6 and height 6. Because every square will have a name set to square, and every rectangle will have a name set to rectangle. So here we can say print info, we say the name with width this and height that, has area of this and perimeter of that. So you can see here, all the square had to do was get a unique name and define a different kind of constructor. It can calculate its area and perimeter just the same as the rectangle did. Of course, it can also decide to become more efficient and redefine it, what it means to calculate the perimeter, for example. You can simply say the perimeter is its width times 4, for example, and this will be true. This doesn't really make a difference, but we know that it might make it more efficient. Now, on a similar note, let's do the same thing for shapes more broadly. So let's just say that we have a figure, let's just say a shape, and let's say every shape has some things. What things does the shape have? Say that every shape must have an area, and we can throw a not implemented error at first. And we haven't really touched on what errors are, but basically this will crash the program. Unless we catch it, which we don't really need to worry about right now, but yeah, basically if we call into the area, this will crash it. This forces us to only use children of the class shape, which will be maybe a square, a rectangle, a triangle, or whatever. And we'll also say a perimeter, which will also be like this. And yeah, now let's say that we are going to define a bunch of shapes. They will have to define an area and a perimeter to not crash. So let's say that we want circles, triangles, and rectangles. Let's say start with circles. For a circle, we know that we need to worry about pi. Let's just define it like this right now. We could just call into math.py, but let's not care about it right now. Let's give it a constructor. In this case, let's say that the circle is defined by its radius alone. And by the way, we don't really have to give it anything else than what the bare minimum to define it. So a circle can be defined pretty much just by its radius. So here we can say softer radius equals radius. And let's define what area and perimeter would be for a circle. So the area, as we know, is pi. Let's say circle.pi. And by the way, it doesn't matter if I say circle pi or softer pi, it's still going to be the same. But yeah, pi times radius squared, so radius to the power of 2. Because we know that pi r squared is the area of a circle, and we know that the perimeter of a circle is 2 times pi times the radius. Similarly, for a triangle, let's simplify and only care about the right triangle for now, because I don't want to get into how triangles work in general. Yeah, we can just copy this. Let's see what this did. We have a side A and side B, from which we can get the hypotenuse ourselves. Let's get hypotenuse. We just return the sum of the squares and then square root of it. Here we would say hypotenuse is self that get hypotenuse. Then we would say that perimeter is side A plus side B plus hypotenuse. All right. Now let's also define a rectangle, which is a type of shape, really, like this, pretty much everything exactly how we defined it before. And now we would say that there is also a square, a type of rectangle, that does everything the same as we defined before. Now, an interesting thing is that right now we basically have a bunch of different shapes defined. So circle is a shape, a right triangle is a shape, and so on. Right here, let's say print info. And here we can see self.class.name with area of this area and perimeter of this perimeter. Here's what this will allow us. Now we will be able to call print info into any of these classes. And this self.class.name, by the way, will just give us shape in this case, circle in this case, right triangle in this case, and so on. So let's test this out. Let's create a bunch of objects. So let's say, in fact, I'm going to create a list of objects, and then I'm going to go through each of them. Let's say a circle with a radius of 5, a circle with a radius of 3, for example, a right triangle with sides of 3 and 4, or with sides of 5 and 12. Let's say a rectangle of sizes 4 and 6, a rectangle of sizes even 5 and 5, nobody's stopping us from making it a square, or a square of size 4. And now for each object in these objects, well, I mean, objects is a taken name, so let's just say, actually, let's call this shapes. Let's say for each shape in shapes, let's print the shapes info to the screen. Now let's see what this looks like. Here's what we get. So the first one we see circle with area of 78.5 and perimeter 31.4. The second one is circle with area of this. Right triangle with area 6 and perimeter 12. Right triangle with area 30 and perimeter 30. A rectangle with area of 24 and perimeter 20. Another rectangle with area of 25 and perimeter 20. And a square with area of 16 and perimeter of 16. So in this case, we can see we have all these different shapes, but since every one of them is a shape object and the shape object defines print info, we can call this on them just fine. And by the way, we are allowed to not have this here at all, but having them like this makes sure that we will get this error if we try to create a shape directly. So like if I try to also create a shape in here, we can see that we'll get an error because of it. Because here we can see subclasses must implement this method right here. So to clarify that, let's actually ignore all that stuff. And even just right here, let's just say sum shape equals shape. And if we try to get the area of this sum shape, you see here, the code will crash. Our program crashed, we got the error. And you can see that the error came from this line. Raise not implemented error, because we intentionally want to be unable to create objects of type shape directly, so that we only create the objects of their children which define the area and perimeter. Yeah. So this is an abstract class because some methods are not implemented. So this is an abstract method. This is also an abstract method, but this is a normal non-abstract method. And in order to be able to create an object of some type, we must basically implement all these classes, or else anytime they are used, they're going to crash your program, basically. We are allowed to create some shape and just have it. It won't crash automatically as long as we don't use the methods. But if we do use a method, then it's going to crash. So yeah. We call it an abstract class, but it's not really, you could say. But yeah, I mean, we have to define this before we can use them is the idea. All right, that's all the main ideas about classes that we need to understand. And let's just go through them one more time. So first, we had some ideas that we could define everything without classes, but with classes, everything can be more organized. Like in this case, we know that every shape has some kind of an area and a perimeter, and that we can print the info about this shape. And then we define what the area and the perimeter look like for a circle, for a right triangle, for a rectangle, and specifically for a square even. We can create all these shapes as a list, and we can call print info on each of these shapes to see what each of them are doing. We saw that we have a constructor which can take any amount of arguments. We can do whatever we want with the class. We can create objects of the class and call things on them. We can change the fields of the class. What else is there here? Let's see. We also have some class methods, which are methods that only use the static or the class variables. In this case, that was number of dogs. In this case, we do not have anything like that. But for a circle, that would be pi, since pi is not changing. And so that's the general idea with classes. Now, this may take a moment to click for like why we would use them and how and such. And this will become more clear with the homeworks that I'll upload soon. But yeah, this is pretty much it for today's lesson. Don't worry if some things don't click right away. This is a lot of new syntax, but we'll go through them with homeworks and we'll dive a little deeper in the homework. So I just highly, highly recommend that you go through the homeworks. Now I'll upload these samples and that's pretty much it for today's lesson. Now, if there's any questions right now, feel free to ask and we can end the lesson. All right. I suggest that you take another look at this once it's uploaded to YouTube. And yeah, that's pretty much it for today's lesson. I'll see you next week.
Goodbye.
Bye.